Ever click a button online and nothing happens? Or try to get simple info from a company and it's
Yeah.
just impossible.
Yo.
Okay, let's unpack this
Mm.
because, what looks simple, these data systems we use constantly, they're often built on something really shaky.
Data modeling.
Exactly. Data modeling is like the hidden architecture. And today we're really diving into why it often goes wrong.
Absolutely. We're looking at insights from someone who's really been in the trenches,
Hmm.
a
Yeah.
consultant who's spent years fixing company systems, wrestling with that data spaghetti.
Right.
We're drawing from a lecture he gave on data modeling strategy. It's some real wisdom from the field.
And our mission here is to pull out those core principles, right?
Yeah.
What makes for good data modeling? Why is it so critical for building systems that actually work? Systems that are stable, adaptable, and don't just, constantly break.
Mhm.
And this isn't just about drawing pretty diagrams. It's way deeper. It's about how you fundamentally think about information.
Well, and our expert kicks off with a pretty blunt observation. His initial shock, really, and often disappointment when he first gets under the hood and sees how companies actually design their data.
Yeah. Like what?
Well, it's this big contrast, right, between maybe the polished reports or the idea they have and the messy reality underneath.
Okay. So you expect this perfect blueprint, this engineered plan,
Yeah.
and instead it's kind of held together with what? Hope and sticky tape.
Pretty much. He found this huge gap between the idea of a data blueprint and the often, chaotic reality. Companies think they have a plan, but
But it's a mess when you look closely.
exactly. And his core point is that these fundamental flaws right there in the structure, they're the biggest source of headaches. That's what leads to all the wasted effort, the late nights fixing things.
Okay, so it often comes down to the initial design being flawed.
And what's really interesting is that it often stems from a lack of clear, objective thinking. Sounds easy, right? We need customer info. But the critical part is why. Why these details? How do we define them? Like, is a customer's name just one field? Or first name, last name? What about titles? Suffixes?
Simple things.
Simple sounding things. But often there's no solid reason, no defensible logic behind those choices.
So it's not just grabbing data, it's the thinking, the justification for how you organize it.
Precisely. And without that solid base, the models end up being really brittle.
Brittle? How so?
Well, they just can't handle change.
Yeah.
Even small shifts in the business can break them. And that's when you get stuck in that endless cycle, putting out fires, data getting unreliable.
Constantly patching things up instead of having a solid foundation.
Exactly. And it seems a common trap is getting bogged down in the how-to. The mechanics of drawing diagrams, using the software, without really getting the know-why,
Yeah.
the actual principles of good design. He uses a great analogy. Knowing how to swing a bat doesn't make you a home run hitter. You need the strategy, the understanding.
That makes total sense. Like knowing how to use the tool, maybe an ERD tool,
Yeah, the entity relationship diagrams.
doesn't mean you actually understand how to structure the data well underneath. It's like knowing Microsoft Word doesn't make you a good writer.
Perfect analogy.
So the key is understanding the why, not just the mechanics of drawing it out.
Right. And then there's this brilliant story he tells about a cameraman, someone with zero data background.
Okay.
And this cameraman gets completely drawn in, fascinated by the sheer logic of organizing information properly. It just shows how much common sense is behind good data modeling.
Wow, that's fascinating. If someone totally outside the field gets it, it really highlights the logical core.
It does. But then he hits you with a counterpoint,
Okay.
which is, even though it seems logical, the reality is most places don't do it well. Knowing what it should look like isn't the same as actually consistently doing it effectively.
That's the gap, knowing versus doing.
That's the real challenge. And he argues that mastering this, data modeling, it's not just some niche tech skill. It's actually a critical frontier for IT professionals.
A frontier. How so?
He compares it to, say, a baseball player versus a manager. The player's career might be shorter, focused on execution. The manager uses years of experience, judgment across countless situations.
I see. So it's about moving beyond just following instructions.
Yeah.
To really understanding the whole landscape, the strategy, especially as you get more senior.
Precisely. For experienced IT folks, especially leaders, having that deep grasp of data modeling is vital. It's the bedrock. It's that shift from just doing the tasks to truly understanding the fundamentals and their impact.
Which leads nicely into his 3 pillars for success, right? And also where things go wrong. The first one is simple and clear design.
Simple and clear design sounds obvious, doesn't
Yeah,
it?
that sounds like table stakes.
But apparently it's a massive hurdle. He uses the analogy of building a house, trying to change the blueprints after you've started building. Disaster.
Well, you can't easily rip out the foundations.
Same with data models. Those fundamental flaws early on cause huge problems later. And he mentions a tricky dynamic, too. Junior folks might see issues in a design from a senior architect, but they don't feel they can speak up.
Oh, yeah. That happens.
And you end up with data that's not transparent.
Yeah.
Data that needs tons of processing in the applications just to make it usable.
So the takeaway is fight for that simplicity and clarity right from the very start.
Absolutely. And it's not just about making it easy to read. It's about actually using your database effectively. He has this interesting comparison.
Go on.
Like luxury cars often have simpler engine layouts than cheaper ones. True technology, he says, leads to simplification.
Huh. Interesting point.
A clean, simple model makes querying easier. It's more adaptable when business needs change. And it's way more efficient with large data volumes. We're talking millions, even billions of rows. That's where good design really pays off.
Okay, so pillar 1, simple, clear design. What's pillar 2?
Technical leadership. It's not enough just to have smart people. You need leaders who deeply understand data modeling and can guide projects properly, right from the beginning.
Makes sense, like having a good general leading the troops.
Exactly. He uses that analogy.
Yeah.
A competent platoon leader gets the team to the right objective. A clueless one, you end up on the wrong hill entirely.
And the impact of that leadership, good or bad, ripples down through the whole team.
Hugely. Strong leadership empowers everyone. He criticizes companies that just hire hordes of junior programmers instead of investing in and empowering a core group of really skilled people.
The 20% rule, maybe? That key group driving most of the impact?
He mentions something like that, yeah. That capable core makes a huge difference. But he also warns about experienced leaders burning out or losing touch with the ground reality.
Right, getting stuck in meetings, losing the hands-on perspective.
Exactly. So he calls for a shift in how technical expertise is valued and nurtured. The key insight: invest in strong technical leaders who get data modeling deeply.
Okay, simple design, strong leadership. What's the third pillar?
Shifting developer mindsets. This one's about how developers actually interact with the data.
How so?
Moving away from that traditional step-by-step procedural way of coding data manipulation inside the application.
Yeah. Okay.
And instead, leveraging the power of the database itself, using a more declarative approach, telling the database what you want, not how to get it step by step.
So letting the database do more of the heavy lifting.
Precisely. But it requires overcoming ingrained habits. Developers are used to writing lots of procedural code, he compares it to. Like even if you've mastered calculus, sometimes those basic concepts of sets and logic can still be tricky.
It's a different way of thinking.
A fundamental shift in perspective about data.
Yeah. And the payoff can be massive, like
Yeah.
10x, even 100x performance improvements sometimes, just by letting the database do its job properly.
Wow.
The problem, he argues, is pressure. Developers often focus on quick wins, immediate tasks, maybe without guidance from management to think bigger picture about the design.
So the core takeaway is change the coding approach, think declaratively, use the database's power.
It all starts with the design, but yes, that's the shift needed. Now, you mentioned ERDs earlier, those diagrams. The expert seems to think that just being able to draw one doesn't mean much, right? There's an illusion there.
A big one. He even quotes a saying, many can draw ERDs, few can design effective data models.
Ouch.
Yeah. Using the fancy case tools, making it look pretty, doesn't guarantee quality underneath. The crucial step, he insists, is thinking deeply about how the information will actually be used.
Because business needs change constantly.
Exactly. They're like chameleons. So the model has to be flexible for the future. He also warns about data silos, data trapped in different systems, disconnected.
Making it impossible to get a full picture.
Right. He uses an analogy. Disconnected wires make good equipment useless. Same with fragmented data, it loses its value.
And he found actual examples of this mess in real systems, like garbage data.
Oh yeah, Orphan records stuff that doesn't link to anything meaningful. Illogical connections created by messy application code. And the scary part,
It's that.
the people using the data daily often don't even realize how bad the underlying structure is because they only see it through the lens of their specific application.
They don't see the chaos behind the curtain.
Exactly. So the modeler's job is critical. Build in that future flexibility, but without making things overly complex. It's a balancing act.
And it's not just theory, right? The design has to consider the practical side, implementation, performance.
Absolutely. Modeling can't be done in a vacuum. If the modeler doesn't understand how databases actually work, they might create something that looks okay on paper, but performs terribly.
So the design needs to enable the database to work efficiently.
Yes, a good model lets the database do more heavy lifting. Poor models create bottlenecks, make it impossible to scale up when data grows. You see huge performance differences based purely on the model quality and the SQL it enables.
It's not just about drawing boxes anymore.
Not in today's world, it's central.
So what are the telltale signs, the symptoms in an organization that point to poor data modeling?
While seeing lots of different, often incompatible hardware and database platforms scattered around is one sign. Fragmented models are another, the same customer table appearing slightly differently in 5 different systems. Redundancy galore.
Yeah, that sounds messy.
Designs driven by business process flow instead of actual data usage patterns, that's a big one, leads straight to redundancy and inconsistency.
And then the painful data cleanup efforts later.
Oh, the data cleansing sagas. And the shocking discoveries about data quality. Lack of proper historical data management is another huge red flag. You can't analyze trends properly.
And unlike bugs in code that you find and fix.
These design flaws, they stay hidden, lurking, until you try a major rebuild and then, boom.
Okay, so how do we create good models? He talked about them needing to be concrete and three-dimensional. What does that mean?
It means going beyond those flat, basic diagrams, capturing rich detail, like clearly defining data subsets, identifying common elements across different areas, spelling out the exact relationships, who uses what data, under what conditions.
More like detailed architectural blueprints than a simple floor plan sketch.
Exactly. A shed needs a sketch. A skyscraper needs detailed blueprints. And he pushes back on the idea that this detail is complex.
How so?
For the people who actually need to build or use the system, that detail isn't complex, it's necessary. The absence of that detail is what creates chaos later. If a detailed model looks too complex to you, you're probably not the person who needs that level of detail to do their job.
Got it. Detail isn't complexity, it's clarity for the right audience.
Aim for that richness.
And then he warned against specific bad ways of modeling these anti-patterns. The first was present tense modeling.
Yeah, present tense modeling. It's designing based only on what you need right now, how data looks today. Like starting by creating a sales table or a payments table, because that's a current process.
Okay. Seems logical at first glance.
But it misses the foundation. What are the core entities? What are their fundamental relationships? It's like building the living room without planning the foundation or how it connects to the bedrooms.
Leads to missing links, illogical connections later on.
Exactly. Things get tangled. He stresses focusing on the core entities and their direct parent-child relationships first. Don't just model the immediate process you see.
Okay, avoid present tense. What was the second anti-pattern? Genealogy modeling.
Genealogy modeling, like building a family tree that only shows, say, the father's side. It's creating hierarchies that only capture one perspective.
So it's incomplete.
Very incomplete. Imagine modeling a company structure just from the view of department heads reporting upwards. You miss all the cross-functional links, other vital attributes of employees or teams. You need all the contributing parts like needing both parents to define a child. You need all perspectives for an entity.
Don't limit the view, capture the whole picture. Got it. And the third, networking modeling.
Networking modeling. This is where you treat key entities like just dots connected by simple lines, like a basic network diagram.
Like terminals on a network map.
Kind of. It fails to capture the richness of the relationships, the dependencies. It's superficial. You see connections, but you don't understand their nature or importance. Leads to a shallow understanding of how the data really works together.
So avoid just connecting the dots. Understand the web.
Understand the web. Exactly.
And the right way to model isn't what he called desktop landscape painting.
Right.
Trying to do it from memory after meetings.
Definitely not. He's very clear. You can't paint a realistic landscape from memory in your office. You need to be looking at the landscape.
So you need to work directly with the business folks.
Collaboratively. Actively engage with the domain experts. Understand their needs. Validate the model with them. Don't be the clueless investigator, just passively taking notes while they talk.
Because they might miss things, or you might misinterpret.
Absolutely. The goal isn't just a snapshot of now, it's creating a work of art, something integrated, future-proof. The modeler is like a photographic artist interpreting and structuring reality, not just a point-and-shoot photographer.
Be collaborative, be active, aim for a well-structured representation.
That's the idea.
And fixing bad models sounds like a nightmare. Huge cost, huge effort.
It really is. Time-consuming expensive. And even after fixing it, you still need that solid structure, that well-organized storage space for flexibility later.
And people just jump to new tech without fixing the foundation.
That's a huge frustration, he mentions. Companies adopt shiny new platforms but slap them onto the same old broken data models. It's just changing the skin, not fixing the bones.
Wow.
He says he sometimes has to justify the very need for data modeling. He compares it to someone asking, do we really need blueprints for this skyscraper? It's that fundamental. You can't leverage new tech effectively without a sound data model.
That puts it in perspective. The foundation is everything.
And the way we process data is changing too, he notes, moving towards simply models.
Yeah, tell me more about that shift.
Historically, you had complex models feeding databases and then tons of application code to manipulate the data for presentation. The trend now is towards simpler data models, with more of the processing, the transformation, happening inside the database or in specialized tools like data warehouses.
Because the databases themselves are more powerful now.
Much more powerful. They can handle complex queries, complex manipulation, much more efficiently than writing thousands of lines of application code. But again,
You need that simple, well-designed model to actually use that power effectively.
exactly. A few lines of good SQL against a good model can do the work of massive amounts of application code. But the model has to enable it.
Okay, that makes sense. He also talked about needing horizontal thinking. What's that about? It sounds like seeing the connections.
It is. It's about adopting that holistic, interconnected view, seeing the whole picture, not just linear steps. He says many struggle with this. They get stuck in a kind of step-by-step procedural mindset.
Like programming logic.
Yeah, and that leads to tangled, inconsistent models.
Yeah.
He even mentioned this odd thing in Korean IT, where systems somehow seem to work despite data inconsistencies, maybe through clever engineering patches that mask the core design flaws.
Interesting. Patching over the cracks.
But it's not sustainable.
So how does this triangle principle fit in? He mentioned managing complexity with that.
Right, the triangle principle. He visualizes the size of work as a triangle. When the work gets bigger, the triangle gets bigger, and often people get confused, overwhelmed.
Yeah, that happens.
He says if that happens to you, you should rethink your data modeling approach. The goal should be to keep the difficulty consistent, even if the scale increases.
Okay, how does horizontal thinking help there?
It helps you break down the big problem into smaller, manageable triangles, units of work that fit your mental capacity. A big project just means more small, consistently sized triangles.
Like climbing a huge staircase one step at a time. Each step is manageable.
Perfect analogy. But the key is each unit triangle, each step, has to be handled thoroughly and correctly before you move on.
No cutting corners on the small pieces.
Because if you do, the triangles start getting too big, interconnected, messy. That's where the complexity explodes. He sees things like unnecessary alter table commands during development.
Ah, changing the structure midstream.
Yeah, a clear sign the initial design wasn't thought through properly. That's a symptom of those triangles getting out of control.
And this explains why projects seem fine, maybe 70, 80% done.
And then they hit a wall. Because the underlying design flaws, the messy triangles, only surface during integration when everything has to fit together. It often traces back to rushing the initial design.
Trying to build too fast without solid plans.
Exactly. He keeps coming back to how that traditional programming mindset, that procedural thinking, hinders good data modeling. The ultimate goal, be able to walk into any new business area and confidently build a solid, defensible data model.
That's a powerful skill.
It really is.
So finally, he wrapped up with 5 key reasons why modeling is so crucial, but also so hard. Can we recap those?
Sure. First, the data model is the core application. Everything else should build cleanly on top, leveraging the database.
Okay, foundation first.
Second, you need an enterprise-wide perspective, holistic thinking across the whole organization.
See the big picture.
Third, redefining existing concepts, surprisingly often. Basic terms like customer, product, they're poorly defined in current systems. You have to clarify them.
Go back to basics, define terms clearly.
Fourth, anticipating future needs, designing for flexibility for requirements you don't even know yet. That's tough.
Designing for the unknown. Yeah, tricky.
And fifth, managing data proliferation. Just dealing with the sheer volume of current and historical data effectively. Modeling is key to managing that for future use.
Okay, those 5 really drive home the importance and the challenge. So wrapping this up, it's really clear, isn't it? Good data modeling is way, way more than just drawing diagrams.
Miles beyond that.
It's a fundamental discipline. It needs clear thinking, objective reasoning, seeing the whole picture, a deep grasp of information principles.
Absolutely. It's laying that strong foundation for pretty much everything data-related that follows.
And it does make you think, about all those systems you use every day. You have to wonder, how well are their underlying models actually designed?
Hmm.
What hidden problems might be lurking there, just waiting to cause issues because of those fundamental design flaws?
It's a sobering thought.
Mm.
But understanding these principles, even at a high level, can give you a real advantage, right,
Hmm.
in navigating this data-driven world we're in, whatever your role.
Yeah, definitely. Because ultimately, that ability to understand information structure, to unpack it, see how it connects, that's just an incredibly valuable skill.
It really is.
And hopefully, this deep dive has given you, our listener, a good starting point for developing exactly that understanding.